Hi, I'm Jacob McCarthy. I lead business development here for UGS Labs, and today we'll be walking you through our service, Cedar.
This is Johnny Boy from UGS Labs, and I'm here to show you Cedar. Cedar is our very own custom-built conditional NFT generator for Solana. And what it means is that imagine you have three backgrounds like red, blue, green, and you have shapes, square, triangle, circles. You only want, let's say, circles to match blue backgrounds, squares to match green backgrounds, and triangles to match red backgrounds. You can do that with Cedar. Also, we have a way to implement strategies for custom naming and descriptions, but a little more on that later. So how does it work? It works with a config file. So I prepared a quick demo configuration and demo assets as well. So as you can see here, we have backgrounds, shape colors, an inner shape, and shape that fits in the corner. What I'm trying to do with this is to get Cedar to match only shape colors different from the backgrounds. So basically, blue shapes won't go on blue backgrounds, and inner shape should match the external shape. In case you have an inner shape, it should be the same. So here is the config file for that. So as you can see, we have the first entry, which is metadata. This concerns the final NFT metadata, I'd say. It's pretty straightforward. It's the information, basic information of the NFT that you will find in any NFT generator and on-chain actually. Collection, creators, description, name, and royalties. Second entry is options. This is related directly to Cedar because here you have the supply, you have the strategies I was talking about earlier, and unique editions. Unique editions is basically a way to tell Cedar that you only want an NFT to happen once. You don't want twice the same result. You can set it to false if you don't mind. Then you have step, resources, and root outcomes. I'll start with steps, which is basically the order that you want your physical and non-physical layers to come on top of each other. From bottom to top, you have here, I put gender for demo purposes that you'll understand a little later. And then, background, shape color, shape, inner shape, corner, because that's the way my assets fit together. Then you have resources. Resources are basically all your layers. So they are related to step. They have outcomes. And basically what you're doing when filling outcomes is telling where does it lead to. So we'll start with male gender. It can lead to backgrounds with a third chance each time. You can have like male, female, it's the same thing. Blue backgrounds can lead to red triangles, red squares, red circles, and green shapes as well. So you're building some kind of path. You could see it like this. You're building a path between attributes. Also, I mentioned physical and non-physical layers because, as you can see, gender doesn't have a blend mode in the steps. Blend mode stands for the blending image mode that you can find in Photoshop, etc., like multiply and so on. But it doesn't have one because it's non-physical. What it means, it doesn't have an image to represent it. Also, you can see that resources have attributes. which is optional as well. This lets you basically do multi-layering. Let's say you have characters with hair, and you have some part of the hair that goes underneath, let's say, glasses, and some part of the hair that goes on top of the glasses. You can do that and have multiple layers for only one attribute. So yeah. This is documented in the documentation on GitHub. So yeah, so we have this configuration, and the last entry is root outcomes, and it's basically our starting point. So let's see how it works. Actually, I'm gonna go with the -c option, which lets me use an alternative config file, because by default it will take only config.json. But you can use this option to use any config that you want. So yeah, let's run. As you can see, all is logged, and you also have cache files that you can see here. So matrix, which is basically the adjacency matrix that I'm using. Resources list, stats, that lets you monitor the quantities and yeah, supply percentages of each attribute. So yeah, let's see how it worked out. Output. So yeah, we can see that we indeed have 100 NFTs, as I asked Cedar, and yeah, let's check. So yeah, we can see that the condition has been respected. I asked shapes not to sorry, I asked shapes to not match the background color. So yeah, and let's see the metadata. So as we have in the metadata, we can find all these informations that we have here. So a little word on strategies. When we made Cedar, we were finding it, let's say, boring to have only, shapes, number one, and descriptions, like just same description for every NFT. So we came up with a way to have custom naming and custom descriptions. So how does it work? We have strategies registry in utils. So we can see that we have a registry for description and naming. Let's check what exists. We'll check Cyberpunk, which is the strategy we will be using for UGS. And descriptions, we have ordinal. So I'm going to close the other tabs, and we will ask Cedar to use Cyberpunk and ordinal. Let's try that. Okay, so let's take a look at metadata. Oh, yeah. You can see that ordinal is like first, second, sixth. Oh, it may have a small typo, but you get the point. Also, you can see that they never have like names according to their gender. Police scrapper. Oh, sorry. Yeah, scrapper. Which is a female. A lot of females. Yeah. So basically, let's show you a strategy. So for the Cyberpunk naming strategy, I'm using a library for the naming that takes the gender. That's why I put the gender, which is non-physical layer. And for the ordinal strategy, here it is. So as you can see, you just have to implement this method, and you can use the configuration, the resources, the edition, and the naming for the descriptions. So let's try to implement one, and cherry on the cake, we'll be using AI, because as you may have noticed, we have templates for OpenAI integration to make it more fun. Close tabs. So yeah, let's call it AI demo. We will duplicate the description strategy, OpenAI demo. Let's rename that demo, and we will take advantage of the shape. We'll ask the AI to make up some fun fact about the shape. So let's get the shape. Equals resources.find. We will find in the list of resources the one that shape. Okay, as resource, and here is a fun fact, because it's a completion, so we have to make it this way. Here is a fun fact about a shape. We'll use the attribute value. Here is a fun fact about a triangle, square, or circle. Okay, as you may have noticed, it works with an API key, so I won't show mine obviously, but here you have a .env file in which you can fill this. Yeah, let's try. Oh, I almost forgot to register the new strategy. So let's duplicate this and make it AI demo. Open AI demo. Then we have to, oh, we already did that. Okay, let's run. It takes a little while to generate because for each generation it makes an HTTP call on OpenAI API. So yeah, already 6. Let's check while it continues. Oh, so yeah, a triangle can be classified by its singles. So yeah, basically there's no limitation besides your imagination here. You can come up with anything you want. And this is the same way to make naming. You can use it, as you may have noticed, we have OpenAI template for naming and description. So yeah, no limits. So here it is, Cedar, custom conditional NFT generator with naming strategies and descriptions. Thanks.